We should start a podcast.
Let's get going. Do you want to start with the Python metadata stuff?
Yeah, sure. So I saw a blog post this week. In fact, it was passed to me by Peter Steinberger, who passed over this blog post from Armin Ranacha, and he thought I might be interested in it. And it's called "Constraints Are Good: Python's Metadata Dilemma," and it's basically a post about a situation that they have in the Python kind of package and dependency ecosystem at the moment, where you can have this thing in Python. I haven't really used, but I've done a tiny little bit in Python, but not nothing worth mentioning, and I wouldn't say that I know the language, or certainly don't know the dependency ecosystem very well in Python. I believe you, Sven, you have done more Python than me, right?
I've used it a fair bit, yeah.
Yeah, so maybe you can guide me through this. So basically, the dynamic metadata is in the kind of dependency manifest for a Python package. You can execute effectively arbitrary code, and that is now causing a few problems: a very slow dependency resolution, and difficulties with cache invalidation, fragmented metadata storage. I'm reading some of the bullet points here from the list of issues in the blog post. And so, first of all, correct me on anything that I've said that's wrong there.
I'd be struggling because setting up dependencies in Python has always been weird. I remember, now this has been a while, I stopped using Python as a development language pretty much when I started on server-side Swift, which was around, I think the last project that used Python ended like 5 years ago now. So it's been a while, but I remember it's always been a pain point setting up a Python project because there's pip to install stuff. Then there was another thing that was kind of, I don't remember. There was also running python setup.py. The setup file was a means to install stuff.
Right, I remember doing that a couple of times.
And I don't remember. There was another one that was controversial, or it might have just been a dependency. I think that might have been a dependency that was setting up. My memory is hazy there, but the one thing I always remember, I was always happy when I had stuff set up and I was successful. It was succeeding to import stuff. That was always the benchmark. Can I actually import matplotlib and not have a library failing to load? Because the problem with Python is if it's a pure Python package, that was never a problem, right? That was always smooth. The problem was always the dependencies that compile C code and
like a wrapper around a C library,
exactly,
or
load a C library, which is sort of also a thing that we are used to in Swift land, right?
Yep, there's lots of that in Swift.
To the credit of Swift, that's way more reliable than the Python stuff, just because Swift can actually compile the C stuff directly, and in Python you need to have the C compiler and whatnot installed at the right versions and all that stuff. It always ended up us writing a Docker thing to set up stuff. It was always a bit of a pain, and reading that blog post sort of gave me the idea, this is even like worse in areas that I wasn't even aware of. So I think this is where I hand it back to you to summarize.
Well, and the blog post does mention, it says the challenge with dynamic metadata in Python is vast, but unless you're writing a resolver or a packaging tool, you're not going to experience the pain as much. And so this is, we're not talking about the entire environment of writing Python here. But what it did do was this, and we'll link to this blog post in the show notes. But what it did do is it reminded me that we have a slightly similar approach in Swift package manifests, which are Swift code and not metadata.
Yeah.
In fact, at the start of the blog post, you always know it's going to be an interesting blog post when the start of the blog post admires the JavaScript package ecosystem. But there is something about the JavaScript package ecosystem which is good, and in fact, there's a few things, and he lists them out here. And that is that the package.json file, which is the kind of container manifest for a JavaScript dependency or a package, is a JSON file, so it is not executable code. It is just purely metadata. And there's a couple of other things here. So there's a one-to-one relationship between a package and its metadata in JavaScript. Every single package has one package JSON file, which is the entire source of truth for the metadata. That's good.
Which is also
are
quite a baffling thing to have to call out, right? You
Yes.
immediately ask, well, hold on, are there package ecosystems where that isn't the case, where it's a one-to-n or n-to-one even relationship?
Swift does also have that one. We're one-to-one with JavaScript at the moment, yeah.
Well, kind of. There's a caveat there, but we'll get to that, I suppose.
Are you talking about the Swift version-specific manifests?
Yes, exactly, yeah.
Yeah. Yes. Yes. I mean, we're already. I mean, Swift still feels it's not a new language anymore, but it still feels kind of new as a language, and already we have artifacts of things like that. Anyway, so the point that I was making here was there are certainly aspects of a Swift package manifest that came to mind as I was reading this blog post about the Python dynamic metadata. And when we've hit problems where the compiled nature of a package manifest causes problems for us when we run the dump package command, which is supposed to turn a package manifest into a JSON file, which is what we can then parse, and that's how we extract all the metadata about a package that we can get. And I think one of the key things that jumped out to me, which is mentioned in this blog post as well, is that based on, for example, platform or environment, you can have your package metadata is not consistent.
Yeah.
It can change depending on where you're compiling it or where you're running that dump package command. And I know there's a whole can of worms around opening a discussion on whether making package manifests code was a good idea or not. And I also know that changing it at this point would also be really difficult. And again, this is mentioned in the blog post. Like once you have Pandora's box open like this, people build all sorts of stuff into that, relying on that feature, and it becomes incredibly difficult to roll it back. I feel with Swift, is it too late to roll it back yet? I think probably not. I mean, we're still. I just read a blog post actually just before we recorded this podcast, which is the plan on when to make the CocoaPods repository, trunk repository read-only, which is their plan to sunset CocoaPods, basically. And I think they've given it a 2-year timeline from now before they'll make it read-only and finally kind of completely shut it down. But Swift PM has, over the last few years, has become hugely popular. But it was around for many years before it became hugely popular. It was around before it was really useful in iOS and macOS projects. And so I wonder whether we haven't quite got past that point where a rethink of the manifest format might be at least an option.
Yeah, I'd love to see that at least discussed, and then kind of decided, looking at pros and cons. I mean, I'm not sure I entirely see the pros there. Just to give some context, just today, incidentally, I fixed a bug that resulted from having to have a compiler installed to render the package manifest as JSON. Right? Our builder needs to finds out some stuff about a package in order to know which build command to run. And on Linux, actually, we run that in a Docker container that didn't have the Swift compiler installed, and this was new. We didn't need this before, but now we did. And I was completely blind to the fact I'd forgotten that our Docker image doesn't have the Swift compiler. So I called Swift.
I saw that. Yeah.
Describe package, and it failed, and then because of the way it was done, it sort of failed silently, and or at least they printed something and it wasn't immediately obvious why that happened. And I think that's it's kind of a heavy requirement that you need a compiler to understand
It
about
really
your
is.
package. And then also it's important, what platform do you run it on, as you said, and what compiler version you're using to do that. That sort of feels like, that's a bit weird. And then we probably see more manifests than than normal because of what we do. Like, we see lots of packages and people ask, well, why isn't this working? And there's some wild stuff going on in package manifests because it's effectively a little Swift script, right? A Swift program, and people
It's code.
program
Yeah,
in it, and you have to effectively. Sometimes I look at these things and I have to pass that program because what else can I do? Obviously, you can
Yep.
run Swift package describe and then get the output, but then that doesn't tell you why stuff isn't there as you expect, and then you sort of have to sift through and people do stuff in there. They import foundation, look at environment variables, imply logic, and you think, oh God, is this? I mean, it opens up possibilities, but I feel like some, as the post says, constraints are good, right? What would we lose if that was just a JSON file?
Well, that's it. And every time I see somebody doing something like that in a package manifest, I think, I kind of wish you weren't doing that. Like, wouldn't it be better if this was just a standard file? Yeah. My go-to example, and I hate to call out a specific example here, but they're a big company, so I feel less guilty about it. My go-to example for this is the AWS SDK Swift package from AWS, which is a 627 line program in a package manifest. Now, to be fair to them, they have 422 lines of targets, which is a lot of targets.
Yeah.
But still, there's code after that, which is doing all sorts of stuff. It's looking at paths on the file system. It's looking at processes and getting environment variables, and it's doing more than you would probably like to think it was doing if it was just a package manifest with some metadata in it.
That's why I'd be really curious to have a proper discussion and see, well, what use cases aren't possible with a static JSON file or YAML file or whatever it is. What would we lose? Or is there even, the dynamism could be just done upstream, right? And the output is a JSON file, right? If Amazon could, in that case, have a Swift script that assembles stuff and then outputs a JSON file instead, rather than keep that logic there on the fly, sort of in the manifest. I can imagine that there's stuff that is really hard to do then, like super platform specific. How would that look like? Would you have sort of logical structures within a JSON file that says, like, this is the dependency tree if it's on macOS and Linux, how would that work? I can see how that can get complex, but that's a theme. The complexity is there, and it's just a matter of how do you package it up, because end of the day, it has to be rendered out at some point. Is that how much do you obfuscate it up front, sort of, is I think my view of it. And there is benefit in having these files more machine readable off the bat without having to transform them, right? Because we always have to make sure they have a Swift compiler and run Swift package describe or Swift package dump package in order to get the JSON out of it. And that's the thing, the JSON that we get out is the thing that we're interested in. That's what we're using. I sometimes wonder if that wouldn't be the better intermediate format to keep around.
Well, so just kind of make that not a generated artifact but a stored artifact.
Yeah, exactly. And then discuss, should there be something that can generate it if you really have a very dynamic use case where you sort of need to generate them, but then also bake them into a package, so you can still be dynamic, and then also write them out so people can actually get metadata info without having to run the process every time, which is something we need to do, right? We have a nightly that looks at packages, and what we do is we fetch all the package manifests in a package, and by all I mean all the versioned ones as well. So we have to make multiple HTTP requests to get all the package.swift files out of a package, and fortunately it's enough to copy these in an empty directory and then run swift package describe. That actually works. It doesn't look at any other things in your package. It doesn't verify that you have a source directory and whatnot. So that's enough to actually dump the package info then. But what we do is then we render a JSON out of it. So that process would be much easier if all we had to do is just fetch a JSON file to begin with, or whatever format is the one that's picked. It's just a lot of work that needs to happen to get that data out.
Yeah. Just to flip onto the other side of the argument and play devil's advocate, even though I am on this side of the argument, there is one advantage to this that we benefit from, which is if it was a pure metadata file, it would be more likely that we would let badly formed packages into the system, whereas the fact that we have to run the dump package before we accept a package into the index, we do get that level of verification that at least the manifest compiles.
Yeah, but I mean, there's JSON schema stuff, right? I mean, you could validate that and make sure that it has all the keys. I'm
back on this side of the.
Yes.
I'm back on this side of the fence. I attempted an escape, but it failed.
Resistance is futile.
Exactly. Well, next week we'll fix the NPM ecosystem and set that right.
Great. There was another interesting post that I see came out last week, Thanksgiving post by Holly Borla, and it's called Prospective Vision, Improving the Approachability of Data Race Safety. I'm sure you've seen that, right?
I did, and in fact, before you go into it, I want to read Holly's Mastodon post where she linked this because it really made me laugh. My favourite Thanksgiving tradition is a good language design debate ahead of the holiday.
Nice.
This time on improving the approachability of data race safety. Well, Holly, I'm so glad that's what's on your mind around Thanksgiving. I hope you managed to at least have some time not thinking about data race safety over the holiday.
Well, isn't the US thing that Thanksgiving you go home to argue with your family? That's sort of that's probably what she's kind of doing with the other family.
I guess so. Anyway, I interrupted you. Sorry, I did see it. Yes.
Great. Yeah, I really like this. I loved seeing this. It sets out to tackle some of the problems that have come up when people start using Swift concurrency, and I think it bears repeating that we are in the early stage of that adoption, and there's been quite a bit of noise because people struggle with it. Right, there's stuff that doesn't go as they planned. Some of it is compiler related. There are some issues that are just growing pain in Swift 6 language mode. So there's some false positives and stuff. And largely this sets out a vision on how to better deal with this adoption. Let me just see.
Yes.
If she has so she says, she opens up, and I should say, I found this post super readable. People often think of Swift language development super in the weeds, and you can't follow, and there is that, right? Often there are parts of proposals that are really technical, and you need to know a lot up front to actually even be able to follow. But
you need to at least be on the same page as a compiler engineer. Yeah.
I don't think this falls in that category. There is certainly stuff that you sort of need to know a little bit about, at least. I think it's a bit hard to judge. I'm not a Swift concurrency expert by a long shot, but I also don't want to. I mean, I've used it a bit, so I'm probably more exposed to it than someone who's just starting out writing Swift, or even someone who's only just starting to convert a project over. But I think I'm not too sort of in the weeds already to be blind to that threshold. I think it's quite approachable, and I think it paints the picture of what the problem is and what they're trying to achieve here. So she opens up saying Swift's built-in support for concurrency has 3 goals, and that's to extend the memory safety guarantees to low-level data races, maintain progressive disclosure for non-concurrent code, and make basic use of concurrency simple and easy, and make advanced uses of concurrency to improve performance natural to accomplish and reason about. And then she goes into, sort of what are the remaining pain points, where what this is about is mitigating false positive data race safety errors in sequential code. And what the thing boils down to, I think, it can be summarized in the default is sort of to assume that stuff is going to be running concurrently, and then the compiler analyzes everything you do with that in mind. So anytime you touch, like global variables, for instance, the compiler will immediately shout, oh, hold on, what are you doing here? Remember, if you do this, there might be other concurrent access, and that's not safe what you're doing. And what this is proposing is to flip this around on a module by module basis. So to open up a mode where the default is to assume main actor isolated code, and that means effectively running a single threaded program on the main thread. And then if you mess with a global variable, that's safe by default, because there's only ever one thread that can deal with that, right? There's no concurrent access because there's no concurrency. And that, the vision is, that should deal with a lot of all of the false positives right now that can happen. And the false positives are really shortcomings where the compiler can't see everything that's happening. And then, because it has to be safe by default, it says, look, this could be problematic. I can't prove otherwise, so I have to warn about it. Or, in Swift 6 mode, raise an error about it. And it's for you to be really explicit about what you're trying to do. And by flipping this around, sort of the premise goes away, right? The initial assumption where there might be a concurrent access isn't actually a problem anymore, because there isn't concurrent access. So that eliminates the need to raise an error by default. And then you can poke holes into that by saying, all right, this is actually non-isolated or has different isolation. And then you can open up to concurrency, and then you get the richer warnings. But you can put this in a mode, and this is a mode that's really interesting, for example, for scripts, or like in general it's proposed to use in executable targets, where you're going to be starting with on the main thread. Like if you write a script, you're probably going to be on the main thread the whole time, right? And then why even deal with all this? And that's the proposal, is sort of to flip this around. I hope I didn't mess this up describing what this is about. Again, read it, because I think it's really readable. The discussion around it that's more in depth, because people raise, concerns. How would this affect this and that? And there are certainly aspects that are more complicated when it comes to classes and inheritance and protocols, and then it gets a bit in the weed. But I think the basic premise is quite graspable. It's quite obvious what this is proposing, and I think it's really well laid out, and hopefully that'll be accepted, implemented, and then could be one of those things. Remember when we discussed this last time, we said this is early days. Just don't rush into adopting Swift 6. By next year, things might be very different and might be much easier. And that actually might be one of those things where you'll have a much easier time adopting this in Swift 6.2.3, whenever this comes out or is implemented. This might be one of those things where you won't have to sprinkle main actor all through your code base, because main actor is the thing that's going to be assumed, wholesale. And you don't need to annotate stuff, because it's sort of baked into the module by module assumptions. There's one other thing I wanted to highlight, and that's from the comments in this thread, because that's also something I at least said before, and I was really glad to see this echoed. And this is Tim Condon's reply to a common complaint that data race safety annotations are a chore. And this is what we talked about. I'm not sure if it was the last episode or the one before. Tim says, to provide an alternative point of view of this, I've lost count of the number of issues and data race issues that have been caught and fixed by adopting sendable across Vapor's code bases. Lots of GitHub issues that were impossible to reproduce, subtle data race issues, and downright stupid coding from myself. Once we adopted sendable, and yes, it wasn't an easy process, especially doing it as an early adopter, all of those issues went away. We've not had a single issue reporting a crash as a result of data race issues. And I was really glad to see that, because I hadn't heard many people say that thing that I've said before about our concurrency crashes that we've seen and that disappeared once we switched to Swift 6. I think it really bears looking at these examples and highlighting those, so it's clear what you're getting, that it's not just a chore that you have to deal with errors, there's something that it buys you. But, and this is also important, and we touched on this as well, to some degree, iOS doesn't have this at the same level, right? It doesn't have the same level of impact on iOS.
I was just about to make that point.
and I vividly remember when I was managing an iOS team, when we were triaging iOS crashes, one of the things I looked at specifically was the number of crashes per device. So the most important thing to fix was we didn't want to have crash loops on a device. If someone has a crash every once in a while, that was all right. If someone crashed, obviously looking at the logs, the crash reports repeatedly, that was a problem. Now, server code is different because you essentially run all the devices, right? You aggregate all the crashes across the whole install base at once. So you have much more incentive to fix that. But, and Tim says that Swift is just more than an iOS programming language at this point, right?
Yes. You're right that it is really nice to see Tim's comment there. I hadn't seen that until I just looked at it while you were talking about it. And it is great to see a story like that. But you're absolutely right that this is a language that has many different uses now, and still the main use is from iOS and macOS applications. So I'm so happy to see this document from Holly. First of all, and we knew that they were still thinking about this, but this is proof that they're still thinking about it. And it's nice to see, like, if you just look through some of the headings in this document, some of the headings are really spoke to me, actually. Easing incremental migration to data race safety. I mean, the fact that is a title in this document it lifts my heart. It's great that's the kind of thing that they're talking about here. And obviously there is the idea that you could switch an application to be single-threaded, because some applications don't need concurrency. It's fairly rare these days. Even an iOS application, a simple iOS application, will probably make some kind of network call, and as soon as you do that, you need concurrency in there. But there are certainly apps that don't need it, and especially as people are learning the language. And I think that's one thing. I wrote a few weeks ago about optimism in iOS Dev Weekly, and I used the example of how easy it is to get up and running with Swift on a new Mac, a brand new Mac. A friend of mine bought a new Mac, and I wanted him to run some benchmarks on package index, but compiling it with the M4 chip to see how it compared to my very expensive M1 Macs that I bought a few years ago. And I was struck by how incredibly easy it was for him, as somebody who is not a developer, to get Swift installed and have what is quite a complex project compile.
Yeah.
It was trivial. And, and in response to that, my optimism and kind of choosing to see the good things about the language, I got some real colourful feedback, saying that even people who are hitting, trying to learn Swift are hitting these concurrency issues immediately, and so I'm so glad that they're really putting this into something that will hopefully be implemented.
Yeah, it sounds like it's really going to take the edge off some of this, the early stuff, and Holly highlights that in an explicit example. I think that it's unfortunate that in some areas you immediately get hit with these warnings when you're doing something, like obvious, in a script, like a global variable, stuff like that. And if this is the way of dealing with that, that's fantastic, because it'll open up these use cases to be much smoother. I mean, we run a script to validate our packages, and then that's sort of one thing where we haven't transitioned over yet, and that's going to be a bit painful, and that might actually be a reason to wait until we have that mode, and then just do it there.
Well, almost certainly that doesn't need concurrency.
Well, it does network requests, and we might pass some stuff, so it's kind of.
But in that script, it could absolutely wait for that network request.
Oh, in the single package validation, yes, for sure. I was thinking about the validator that crawls, does all packages and looks at dependencies. Yeah, that's another one. Yeah. I mean, all of this, it's just great.
But we've talked far too long about this stuff, so we should get to some packages before people just stop listening.
Yes, let's do some packages.
Do you want to start us this week?
I'll kick us off. My first package recommendation isn't a package recommendation per se. It's a package search recommendation. I came across a social media post a couple of weeks ago about a project called LMDB, which I'd never heard of. So this is sort of a key value store database which has fast transactional ACID transaction support, thread safe, crash proof, broad platform support, and the person wasn't posting about Swift. This was just a general recommendation to look at LMDB when you might be looking at SQLite as sort of a similar project, but SQLite is very relational, and this is a key value store thing. So this might be, if you have key values, that might be more fitting. And then I thought, it's interesting that I'd never heard of this. I wonder if we have wrappers, because it's a C-based project, I believe. I thought, well, maybe we do have wrappers, and I ran a search, and I was really delighted to find quite a number of packages related like this. I'll name 4. There's a couple more even, and obviously just the plain C wrapper as well. So we got Quick LMDB, Rapid LMDB, Swift LMDB, kind of a theme here in the names. And then Empire is a quite differently named one. And these all wrap this and have various different APIs. I didn't try any of them, but they looked well maintained and had different ways of dealing or adding an API on top of it. I thought that was really nice to see that this is represented, and I think the database itself seemed quite interesting. So if you have a need for a key value store, give this a try when you normally perhaps would have chosen SQLite. I think that's a nice alternative if you need something like that.
And does it have any? You may not know this, but does it have any dependencies on other? Is it built on top of another SQL? Another key value store, or is it purely implemented inside this package?
The packages themselves probably pull in the C sources, but the LMDB itself, I think, is a...
so LMDB is the underlying... Okay,
yes, I got it. Yeah, it's sort of, think of it as, this is SQLite, an alternative to SQLite, which has the same thing, right? You typically have SQLite interfaces by pulling in the SQLite C sources and then building those and then adding richer APIs on top of it, and that's what these packages are generally doing. I haven't looked at all of them in detail, but I've seen a couple explicitly call out that they're wrapping the C sources, or the under. I think it's C under the hood. They're pulling.
Right.
Well, it must be a C or C++, I suppose. So yeah, there you go.
Great. My first package is called Fuzi, Fuzi, and the developer name is Dimension Dev. I'm not quite sure who's behind it, but it is actually a port, or at least it's based on a port of Matt Thompson's Ono library, which was, I think, an Objective-C library back in the... Well, yeah, I've just looked at it. It's more than 10 years old, the Ono library, and the last commit was 5 years ago. So an abandoned library for parsing XML. So obviously Swift can parse XML, but unlike JSON, XML has kind of died as an interchange format these days, often for good reason. You know, JSON is very much more efficient in terms of size and all the rest of it. So there are huge and significant reasons why JSON won that battle, but certainly people still need to parse XML from time to time, and the APIs built into Foundation for parsing XML are okay, but they're a little outdated compared to how we interact with JSON. And what Ono and more recent Fuzi library do is try to bring a more Swift friendly syntax to parsing and reading data from XML files. So it's still powered by libxml2 underneath the covers, so very, very fast parsing from that. Supports XPath and CSS queries, auto conversion of dates and numbers. It can load HTML and XML documents from strings or NS data. So it's got all the kind of basics, but then there are some things in Fuzi that have been improved as well. Mostly the Swift style API, no more return types like in any object. So you're much more type safe with this new framework. Right. Some customizable data number formatters. So there's a few other things as well, but effectively it's a modernized and easier way to access and parse XML, which if you still have to do that, you might be interested in checking this out.
Nice, that looks great. And you know, such a rich history, 9 years in development, that's amazing.
Yeah.
And you see the sedimental layers. If you look through the README, there's pod install, there's Carthage update. It has all the different means.
Actually, I may have been slightly tricked by this. I've only just realised the one that the Dimension Dev one that I've recommended here, and this is not the first time I've done this. It's actually a fork. So Fuzi itself, the original packet is by Sei Zheng, and what we'll do is we'll pop a link to both of these in the show notes, because what I didn't realize is that this is a fork. So I'm not sure. I'm only just learning this now. I'm not sure how different the version I saw in the new packages list is from that fork. But certainly either of them are an enhancement over the standard XML document and XML parser classes. Great.
Very nice. Right. My second pick is called Orb by Siddharth Mehta. This is a lovely package. It creates Siri-like orbs, and by Siri-like orb I mean that swirling, like
yep,
circle animation when you bring up Siri on your phone or on the Mac. I think it's sort of universal thing. And it has many other variations as well, and the README is really nice in showing those off. So there's a number of this mystic nature, sunset, minimal, it's different color themes, and I suppose different animations as well. I don't think there's anything. No, it's not actually showing a video, because I imagine the animations might be slightly different depending on which one you pick. But you get an idea for what color they look like. So if you need an orb, and who doesn't, this is a package for you, I suppose.
Well, who doesn't need an orb in these times?
Yes.
All right, my last package for this week is called Solver Core, Soulver Core, by Solver, the company who produced the Mac app Solver, which is a calculator app which I've used for many, many years now, and I dearly, dearly love it. And the unique thing about the app is that it's kind of like a cross between a spreadsheet and a calculator. So you can type in lines of text which get evaluated. So you can type in a mathematical kind of equation or something like that, and it will give you the answer to that. Sorry, not equation. Type in just 3 + 4, and it will give you the answer to that. But then you can refer back to previous lines. So you can say, take the output of line 1 and multiply it by 20, and then carry on like that. And over the years, it's become more and more capable. You can bring currency conversions in there. It makes requests out to get up-to-date currency conversion data. And the reason I noticed it in the package feed this week is that they've just released a version 3 of this library, which I guess tracks a feature they've just added in the application itself, which is that you can have place data inside calculations now. So you can say, for example, what is the time in Ubud, Bali, and it will tell you that, and
nice.
It knows where places are. So you can say, what's the distance between London and Anchorage or something like that, and it knows about places. But what I really want to talk about with this is how this has been split out into. So mostly what I've been talking about so far is the app called Solver, which you should absolutely check out if you haven't used it already. But what Solver is built on top of is this Solver Core package, which gives you that calculation engine in a format that you can use, including all these fancy features like places and currencies and all the rest of it, that you can embed into your apps. And I've seen many apps now implement this. So, for example, if you're in like a design application and you wanted to say, well, this box that I'm editing is 10 pixels wide, and I wanted to actually make it 10 plus 8 pixels wide because I'm adding 8 to everything, let's say, in a whole load of boxes. If you put Solver Core behind those text boxes, they become little calculators where you can just on the fly do calculations, and that's such a powerful feature. Now, the one thing I should mention here is that this is not a completely free or open source license. This is, I'll actually read you the bit from the bottom of the README file because it's important to note this before you kind of go off and start using this project. You may use Solver Core in personal or private projects, but please email us if you wish to use it in a publicly available or commercial project. So it's fine to play around with it, it's fine to implement something, but before you actually ship anything with it, you need to contact the company. And it is actually there is a binary target in there, so this is also, you don't get the full source code for this calculation engine. But I still think it's worth checking out because it's such a powerful concept, I think. I love it.
Yeah, I mean, Solver is just such a great app. If there's a library that allows you to do similar things in your own code, and even if it's just a personal project, I mean, that's just great. I think that's a fantastic tool. Well,
I've spoken to the developer is Zach Cohen, and I've spoken to him on several occasions actually, and as I understand it, Solver itself is built on this library, so this is the real thing. This is not some pale imitation. This is it. Yeah.
Very nice. All right, my third and final pick is called Q by Matt Mazicott, and I think this time I actually pronounced Matt's last name correctly. I've messed that up a couple of times in the past. Apologies, Matt.
Yeah, I saw a podcast with him. I think it was the dev diaries that we were on.
Yes, yeah, exactly, yeah.
And it was at that point that I realized that we've been pronouncing his name wrong. Sorry, Matt.
So we spoke about Swift 6 and concurrency earlier, and this is a really nice package to give you an async queue. So, one of the problems with structured concurrency when you do task groups is you have no control over the execution order of stuff. If you have async blocks and you queue them in these task groups, they can come out in like not entirely random, I suppose, but you can't rely on the order really, and this fixes that. So it's effectively like a serial or concurrent queue, just like dispatch queue, that you can enqueue async blocks on. And if you run it serially, like you would in a serial dispatch queue, you really have execution order guarantees what you get out of it. So that's really nice. It has a couple of other API extensions, like something like a barrier. Have a look at the README. It gives examples. I think it's really obvious what it does and how to use it, and it might be a really good tool, especially when you look at transitioning over and you might have a serial queue and might not know how to transition that over into Swift 6 concurrency. That this might be the thing you need in that case. So that's Q by Matt Massicott.
And I think that brings us to the end of another episode of the podcast.
It does.
So I think this will be the last podcast for this year, because we're absolutely careering towards the holidays. And I have a feeling this will be the last one for 2024. So thank you so much for listening. Even whether you just listened to this, if this is your first episode you've listened to, or whether you've been with us since the beginning, I really thank you for sticking with us. And we look forward to giving you more of the same and even better in 2025.
Yeah, exactly. Thank you. And see you next time. Bye-bye.
All right. See you next time. Bye-bye.